Hi everyone. This week we'll be talking about some aspects of ancient Greek mathematics. The mathematics of the ancient Greeks is particularly important in the history of mathematics because it, more so than that of any other ancient civilization, has influenced the way that we think about and practice mathematics in today's world. So what is it that makes Greek mathematics so special? One reason why it's special is that it focuses on concepts rather than merely computations. For example, in the ancient Egyptian rind papyrus, we see that the scribe is asked to compute the area of a round field. The Greeks, on the other hand, are more concerned with the concept of area. What is it? Another thing that makes Greek mathematics special is that it's driven by what are called axiomatic systems. An axiom is merely an assumption that we make about something. So if we want to build maybe a mathematical theory, we start with a few assumptions or axioms, and then we work from there using logic to produce a theory. Euclid's Elements is a very good prime example of an axiomatic treatment of geometry. Speaking of which, the mathematics of the ancient Greeks is largely geometric, as we shall see. Now, the ancient Greeks were active in mathematics for more than 1,000 years, and we certainly cannot talk about everything that they did in those 1,000 years. However, we can touch upon a couple of things that they did. One of the things that we're going to look at is how the Greeks used compass and straightedge to investigate areas of certain regions. Remember, a compass is merely a device that one uses to draw a circle with a given radius. A straightedge is a ruler, an unmarked ruler, that one uses to draw lines. Using these tools, Greeks could create all kinds of different objects. One of the things that they liked to do was to investigate the areas of certain regions by using straightedge and compass to take that region and construct a square of equal area. That's a good thing because we can all find the area of a square. One of the great accomplishments early on in the history of Greek mathematics was Hippocrates of Chios managed to take a curvilinear figure called a lune, it's a crescent-shaped region, and use straightedge and compass to produce a square of equal area. This convinced or helped convince the Greeks that it might be possible to square the circle. That is, if I were to hand you a circle of radius 1, say, the goal would be to construct, using compass and straightedge, a square of equal area. However, the Greeks were not able to accomplish this, and no one else was able to accomplish this either. It turns out there's a good reason for that, and that's because it's impossible. This was only discovered in the 19th century, thousands of years after this problem was first posed. And the solution, the reasons why it's impossible, turn out to be based on algebraic principles. Okay, another thing that we will be discussing this week is Euclid's Elements, which is a very, as I said earlier, it is sort of the hallmark Greek work on geometry, and it rests on axioms. There are 5 axioms that it begins with, many of which just have to do with simple things one can do with compass and straightedge. And from that, the entirety of Euclidean geometry is built, including all of the things that we know and love about right triangles and parallel lines. One other thing that you're going to do this week is you're going to read an overview of the entire history of mathematics, 60-page overview in Math Through the Ages. And you'll be taking a quiz about that overview at the end of the week. Anyway, I hope you find a lot about this week that's interesting, and I hope you enjoy your work. Good luck.